So today we are going to work on making some connections with vocab and getting us into starting that idea of writing a proof. We're going to use some keywords and we're going to say what kind of conclusions are we able to make from these keywords. So in the following diagram, it is given, so that would be like in a proof you would see given C is the midpoint of AB. And what can we say from that? So if C is the midpoint, we know it's going to cut a segment into two equal parts. So the two equal parts that we're going to get are going to be AC and BC. So we can say, knowing that C is the midpoint, AC has to be congruent to BC. Now it says why. So if I'm thinking two-column proof, that would be the reason part of it, or the right-hand side. And we could say something like, well, midpoints split a segment into two equal parts. So just saying, what does this vocab word tell me? What can I say from it? What kind of conclusions can I make? And a why. Why is that true? Okay, below, again, we have a diagram and we are given that we have segment MBN and we have segment AB is perpendicular to MN. So it says, what's the first given the fact that we have segment MBN tell us? And really the only thing that we can say here is that points M, B, and N are collinear, meaning they are all on the same line. Not only are they collinear, but this is also going to tell us the order that they are in. So I know that it has to go M, then B, and then N. So B has to be in the middle. Okay. What are we able to draw from the fact that AB is perpendicular to MN? Well, we know perpendicular lines form right angles. So I could say angle MBA and angle NBA are right angles. And then the question is, well, can we say that MB is congruent to NB? And we'd have to say no. There's nothing on there that says that it's bisected. There's nothing on there that says that it's a midpoint. So there's nothing stating that B is a midpoint or that AB bisects. Segment MN. Something like that would have to be stated in order for us to know that NB and NB would be equal. Okay, looking at question 3, so it says in the diagram, D is on side AC such that BD is a median of the triangle. So if I just stop right there, knowing what a median is, I know a median says that it goes from a vertex, which is B, to the opposite side at the midpoint D. So knowing it's a median, I do know that D is a midpoint. Knowing D is a midpoint, that would tell me that segments AD and CD are equal. So he wants to know, what are we not able to conclude? All right, well, let's take a look at maybe some of the things that we can. We've already said that D is a midpoint, so that's good. We've just said that AD and DC are equal, so that's good. If I take a look at step 4, it's saying, well, AD plus DC, if I put it together, equals all of AC, so that's good. Just because I have a midpoint, it does not mean it will give us two equal angles. Angle ABD and angle CBD, there's nothing on there that says if or why those two angles should be congruent. A median will not tell you that. Okay, on the back we're going to make a couple of more conclusions. And it says we're looking at the whole segment. So kind of like what we just did on that last question. It says make a statement about how the whole measurement relates to the individual parts. So this whole segment, I could say all of AT is made up of the two parts AF And to that, I would need to add on FT. Okay, we can do the same thing with the whole angle. So the whole angle, angle NRS, is made up of two smaller angles. We have this little angle, angle NRK, and to that we could also add on the measure of angle KRS. Okay, so it says in order to justify both, what would we say? Well, we can always say, and we use this quite a bit in proofs, the whole is equal to the sum of its parts. We will use this quite a bit when we're doing proofs. We're going to use this down below. So we have a proof, and things that we want to make note of. We know that CE and FE are equal. We know EB and ED are equal. So I'm going to mark this. We have CE, so that's the segment here, and FE are equal. And then we also know that EB and ED are equal. So this is equal to this. And we want to prove CB, the whole segment, is equal to the whole segment DF. And it says first, make up a test case using numbers to make sure that we understand what the given lines illustrate. So for instance, let's say for instance I know CE is 3. Well, since CE is equal to FE, then that means FE is 3. If I look at segment EB and I say EB is 5, well, since EB and ED are equal, then that means ED is 5. Now, from up above, we said the whole is equal to the sum of its parts. So all of BC should be equal to 5 plus 3, which would give us a total of 8. And if I look at FD, same thing happens, where I would add up the two parts, 5 plus 3, and I would get 8. So algebraically, I can see that has to equal. Okay. So now we're going to do the proof. So this was just a little bit of work to kind of get our brains thinking, would this at least make sense numerically? Okay, so how do we do the proof? Well, the proof. Step number 1, that's always our given information. Okay, step number 2. Number 2 might be a little hard to see. Number 2, I am taking the segment here, CE, notice it stays. I'm taking segment FE, notice it's over here. So I've added EB onto CE. I have added ED onto FE. And so what happens here is we call this an addition. I'm adding equal quantities to each side. If I were to put EB in on this segment, well, I have to add something else that it's either the same thing or that it's equal to keep the equations balanced. So there we have an addition. Taking a look at number 3, CE plus EB is equal to CB. Well, if I look at the picture, and I see where CE is, and I see where EB is, and I put it together, I can see that that's equaling the whole segment. And the same with this next one, FE plus ED, it's equal to FD. Here's an example where we have that property, the whole is equal to the sum of its parts. And our very last line here, how do we actually get to the proof? Okay, well, if I take a look back up at number 2, I have something that looks like CE plus EB. Well, I see that. I see that from line 3. I see a CE plus EB. I see that right here. But it's saying anywhere I see that, I could replace it and call it CB. Then I have the same thing. I see FE plus ED. Well, here's FE plus ED in line 3. And that's saying anywhere I see that, I could replace it and call it FD. So what we've just done is a substitution. Okay, so the one line that we learned, which was coming from number 2, was that addition property. If equals are added to equals, their sums are equal. So that's kind of an introduction into some proofs, a little bit more with some segments and some angle properties. We'll practice this more in class. Please come see me if you have any questions. Hope this helped. Have a great day.